so welcome to lecture 5, exception handling and text I/O. So with text I/O, you need to understand exception handling. With exception handling, we're going to see that Java does things differently, and we are forced to handle exceptions. So we're going to talk about what exceptions are, why do we need to care about them, what other things are available besides exceptions, why should we only use them when it's needed and not just for everything. And then we'll move on to working with files, specifically text files with text I/O. So exception handling. What is an exception? What is an exception? If you talk about a person or a thing and you say that thing is exceptional, what does that mean? Something that goes against what is normal, something that stands out. It's not ordinary. Extraordinary, 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 out of the ordinary, something more. So same thing happens with when we write programs. Something can happen that is not the normal flow of operations. When we write code, we expect things to go line 1, line 2, line 3, line 4, maybe jump to line 6, line 12, if statements, all of those kind of things. But we expect them to move in a specific order. So with exceptions, specifically now talking about the programming context, it's an event that occurs during the execution of a program. So program has to be running for this to happen, that disrupts the normal flow of instructions. You start off with trying to do something, something goes wrong, and then now you are in a state of an exception happening. Some event happens that breaks that normal flow. Now for exception handlings in Java, we have two types of exception classes, or categories, if you will. Unchecked exceptions. These are exceptions that can occur, but Java doesn't force the programmer to handle them. And then we have checked exceptions, where the compiler will not compile your code until you handle that exception in some way. And there's a few ways which we'll look at how to handle exceptions. So it's very important to note, exceptions are going to be everywhere. Some of them you have to care about because they're checked exceptions. Some of them you don't have to care about explicitly, but if you want to, you can. So unchecked exceptions, if you want to, you can, otherwise not so important. Checked exceptions, you have to worry about them, you have to deal with them. In order to understand exceptions, you need to understand the exception hierarchy. Everything is going to be a class here, and then you can see something called object, and we'll talk about that in more detail when we get to advanced object orientation. Some of you might have figured out, but let's spoil the surprise a bit early. Everything in Java inherits from object. Even the classes you create, and you don't even say that it extends or works with another class, by default, it extends Java lang object. That's why you see object at the top of the hierarchy here. So this diagram shows a UML class diagram without the extra things, so no attributes, no operations available, just the name of it, and it shows the inheritance between different classes. So we can see that we have something called throwable that inherits from object, and from throwable you have two branches that we need to worry about. One branch is called error, one branch is called exception. Errors are something we programmers can never ever deal with explicitly. There's no code we can write to fix these problems. Things like linkage errors. There's a class file that didn't link properly. Us as programmers, we cannot do anything about that because we are not involved in the compilation process. We are not involved in the linkage process. Virtual machine error. There's something wrong with the Java virtual machine. Again, us as programmers cannot solve that problem. Virtual machine error like the host system does not have enough RAM. We can't go install more RAM on someone's computer to make it run better when you're writing code. It's not physically possible. So we can't worry about those type of things. You can advise the people who are using your programs to say that these are the minimum requirements. You need 4 gigs of RAM. You need 8 gigs of RAM. But you can't actually go and force someone to not run it on a system that only has 2 gigs of RAM. So those are errors in the sense that we cannot do anything about them. When we get to exceptions, those are things we can look at. Those are things we can deal with. So this is obviously not the full hierarchy of all the different classes of error and exception. These are the ones that are going to be relevant to us in the future. So you'll see there's some things like IO exception, something that's going to be important when we work with input and output, specifically working with files. Then there's class not found exception. When we work with advanced object orientation, we work with the class hierarchy, that's going to be very important. And then you get a subclass of exception called runtime exception, and these are your unchecked exceptions. Everything that is not a runtime exception is usually a checked exception. The programmer has to worry about it. But runtime exceptions, we don't have to worry too much about those. For example, arithmetic exception. If we have a situation where you divide by 0, what's the answer when you divide by 0? Well, it depends who you ask. If you ask C++, you might get some interesting results. If it's a signed int or an unsigned int. If you ask JavaScript, you get other results. If you ask C#, you get other results. For us who work with maths in a more real space, it's not really defined. But on a computer, it might give you something like NaN. NaN stands for not a number. It might give you positive or negative infinity, depending on which operating system, which programming language you use. So those are the type of things that can happen with Java. In Java, if you divide by 0, you get something called an arithmetic exception. Division by 0. That's an error message that you get along with the exception type. Null pointer exception. We've seen this already. If you try and access a memory location that is not initialized to something, you try and access that null reference, you're accessing nothing. Array out of bounds exception. You're working with an array, you go out of the bounds of the array, you run into problems. Now, all of these things, maybe not arithmetic exception, but if you look at the other two, null pointer and array out of index out of bounds, you have seen places or written code where these exceptions could occur, but you didn't have to worry about them. You didn't have to write code explicitly to handle them. You could if you really wanted to, but you didn't have to. Same thing with something like illegal argument exception. This you wouldn't really see anytime soon. We might see it in the future when we're working with more complex classes available in the Java runtime environment. That will be things like, we'll see an example of it where we pass a negative number when we expect a positive number. Then you can do something like an illegal argument because negative numbers are not supported as an argument for whatever method or whatever constructor we're going to be using. So we can also create exceptions if need be, but first we need to know how to handle them in general. So how do we handle exceptions? So you have this analogy, and you should have seen the same sort of analogy in C++, where you try something, and then you have multiple catch statements afterwards. So I don't know how well this metaphor will work, but we'll try it anyway. So in the circus, or performers that walk across a tightrope, when they walk across the tightrope, it's usually high in the air. And they take very much care when they walk across. They try to walk across. And if something bad happens, usually there's a net at the bottom to catch them. It's catching the exception. They don't want to fall. They don't want to get hurt. But there's something there to catch them if something should go wrong. So the same kind of thing applies here to the code. You try and do something which you want to work correctly, but you make provision for when something does go wrong. So here, the first type of way of handling an exception is to use a try catch block. So try any code that's in the try section, so between those open and close curly braces on line 3 and 6, you try to do something. If in the process of trying to do that thing, things don't work out correctly, then what you can do is you can catch an exception. You don't only have to catch one type of exception, you can catch multiple types. So if there's a situation where more than one exception can occur, you can handle each one of them a little bit differently. Maybe if you got division by 0, you can provide a custom error message to the user. If you got a file not found exception, you might give a different error message to the user. So there's different exceptions you can handle, and the order in which you put them is very important. You put the ones most specific, so the ones that are further down the class hierarchy first, and the ones that are more generic later on. We'll see an example of this a bit later. The second way we can handle exceptions is say, it's not my problem, it's someone else's. Now, typically when you write code, especially for this module, you will not do this. It's your problem, you fixed it, you handled it. But there might be some reason in a library, for example, where an exception can occur and it will be handled somewhere else. So in that case, it's sort of like catching the problem and say, okay, there's something happened here, not my problem, give it to someone else. We throw it to whoever called our method. So usually you have a chain of calls. Main method will call a constructor, constructor will call a method will call another constructor, whatever the case may be. Somewhere down the line, an exception gets thrown, something wrong happens somewhere, and if we don't want to handle it at that point, maybe we want to handle it at an earlier point in the call hierarchy, then we can say this method throws these exceptions, and then whoever's calling this method knows that those things can occur. Now there's a little note there that says if you are doing something in main, you never ever throw or indicate that there's some throw that happens inside of main. Because who handles exceptions that get thrown in main? No one. Operating system doesn't handle it. It's the entry point of the application. So if there's an exception that gets thrown there, your program crashes. The whole point of exception handling is to prevent the program from crashing. If something goes wrong, stop the program from crashing and try and go to a state where we can continue. Say, for example, we ask the user for a file, and the file doesn't exist. What's better, the program crashing, and then the user has to restart the whole process, or indicating to the user, please enter a correct file name, or file not found, please enter a correct file name. Which one's better, crashing or asking the user for another file? Asking the user. We don't want the whole thing to crash. What if you type a syntax error and the Java compiler said, nope, sorry, deletes all your code? Would you want to program in that situation? I don't think so. I wouldn't be very happy. So 2 questions at the back first. Okay, so throwing, we'll talk about just in just a moment. Yeah, we'll talk about throws in just a moment, but that throws keyword there just says this method can potentially throw an exception of the whatever type. We'll talk about how do we throw in the next slide.
In C++, the reason we had to be so meticulous about the order of our catch blocks was because the moment a catch was triggered, it would exit the current method. Is that also the case in Java? So is that why we never throw it?
So, question was about the order of your catch blocks. So with Java, it doesn't exit the method when you do your catch. It exits that section at that point when the exception gets thrown in the try section. So we can still have code that executes after your catch block. But we'll look at how that gets done and what sections of code needs to run in the next few slides. So the order is more important that you work with the correct hierarchy order, because say, for example, I have a catch statement with runtime exception, and I have a catch statement with exception. If I say catch exception, it catches anything in the hierarchy. But if I say first runtime exception, it will first do the code for runtime exception, and then only afterwards, if there's something else to do exception. So we're trying to avoid the situation of doing a catch everything when we need to do specific tasks. And if we need to do specific tasks, it needs to be the specific class in that case. So here we can just say, it's not my problem, give it to someone else. There's another way we can handle things, where we handle part of the problem ourselves, but still pass on the problem to the calling function. So here, again, there's a method being defined, but we indicate it throws an exception. And here we have a try catch block again, but in our catch block, we rethrow. We throw again the exception that we caught. So what could be a situation where you would use something like this? If we have a situation where the user was trying to do something, and we're trying to keep track of what the user is doing, an exception occurs, we can write information to a log file, for example. The user clicked on this button, then they clicked here, then they chose this file. Oh, wait, something went wrong. Indicate what happened. Go back to the calling method. Indicate some more things that happened. Restart the process. This is very important to something which we don't really cover in second year, but that's going to be important to know as a developer in the future, and that is bug fixing, debugging, and maintenance. You need to know when something goes wrong, where to go find the thing that went wrong. Now, in the programs that you write right now for computer science 2A, 2B, etc., how much do you think you're writing? How much code do you think you write on average for a project? Maybe 100 lines, maybe 200 lines, maybe 500 lines. Not that much. 1,000 lines, maybe 1,000 lines. Yeah, practice, I don't think even you write that much. That's not a lot. A developer working in industry, starting job, they'll probably write 4,000 to 5,000 lines or look at 4,000 to 5,000 lines of code a day. And that's just on one small project in the whole company or on a big project. Now, if you have to go and look through 100,000 lines of code to find one place where the bug occurred, would it be easier just to go and say, okay, I'll look in this file, let's go and look at the whole file, I'll go and look in the next file, look at everything? Or would it be easier to look and say, okay, the user was trying to do this in this method, let me go and look at that method? If you have a way to trace what the user was doing, it's easier to go and see where the problem actually happened. So that's one place where you could use something like this, where you need to rethrow the exception, is when you need to do some extra operations before you give the exception handling to another method. Now, there are certain situations where you try and do something, and regardless of whether an exception occurs or whether an exception does not occur, so the good code runs or the not so good code runs, you want something to happen. You want the code to run no matter what. In that case, you have another block at the end, after all your catches, something called finally. And whatever you write in the finally section will always happen, regardless of if the file, or in this case, an exception was thrown earlier. We'll look at the case with the file in just a moment. So if we say, for example, we were working with a resource like a file. Let's say we open the file open find. We try to write something to the file. Something goes wrong. After we work with the file, what do we need to do with that file? Close it. Do you remember RIA? Resource acquisition is initialization. Ring a bell? Well, it should. You did it in 1B. There's a lot of things which you did last year, and I'm going to reference it. If you don't remember, you need to brush up. So anytime you work with a resource, whether it's a file, whether it's a network stream, whether it's some other sensor or whatever it is, after you use it, you need to give it back. We used to do that with memory. After you use the memory, you give it back, you delete it. Java says, okay, you don't need to delete pointers anymore. But that doesn't mean we don't stop working with resources. Files are resources. Open a file, you work with this file, you close the file. When you get to Computer Science 2B, you're working with networks. You open up a network stream, use the network stream, close the network stream. If you ever do an honors module where you work with sensors on a Raspberry Pi, same thing. Open up the sensor, query the sensor, close the connection. If you leave it open all the time, you're using power all the time. And on something like a Raspberry Pi, something like a small factor device, you don't want to use power all the time. So the finally block will always run. We can write code there, for example, with the file, to say always close this file. Open the file, try and use the file doesn't work, close the file. Open the file works fine, close the file. If we write the close instead of try section, and an exception occurs before the close statement, that close will never happen. We'll never close that file. And that's a problem. If you never close the file, that means the file can't be used by any other process on the computer. And that might lead to issues when you try and do some other code in the same application or use a different application. So we've seen the theory of what exceptions are, how to work with them. And now we need to talk about when do we actually use exceptions. Now, exceptions don't come for free. When an exception occurs, a lot of things need to happen to indicate there's some problem. Especially when you use the try-catch blocks, a lot of things happen internally with the running application, with the Java virtual machine. So exception handling makes it easy to see what is normal code, what is not normal code when something goes wrong. But when an exception happens, a lot of things happen. Namely, you need to create an instance of the exception object. Maybe it takes up a lot of resources, maybe it doesn't. You need to roll back the call stack. Now, that's a very technical term, call stack. You learn about it in, you sort of know about it already. You learn about it in more detail in Computer Science 3B. But it basically indicates which methods are being called one after the other. So you know method A called method B called method C. That's the call stack. First A, remember stack goes upwards. A, B, C. Then you know the order. You have to roll back the call stack. So you have to say, okay, C didn't actually work. Take it off the call stack. All the parameters, everything, you need to get rid of them, reinitialize your memory, working on all that. That doesn't come for free. That takes time, takes resources. And then you have to tell all the other methods something went wrong until you find the method that will handle the exception. So there's a lot of resources being used to work with an exception. So when you're trying to write code, only write code that needs to be in exception handling if it is required. Something like a null pointer exception. Do I need to do a try-catch block for a null pointer exception? Does it make sense? If I could just handle that with an if statement. Can I check if a reference is null using an if statement? Can I check a null reference exception with a try-catch block? Yes. Which one is less resources? An if statement. There's no try-catch block. There's no exceptions need to be, call stack net needs to be generated or rollback. There's no exceptions that need to be generated. None of the problems, but I can do something about it. Another thing that's available to do checking of sorts is something called assertions. Now, the reason why we need to talk about assertions is because people get the term mixed up with exceptions. They are not the same thing. Assertions are used to assert certain things in your program, to check if a variable is true when you think it is true, to check if a condition holds when you expect it to hold. It's expectations of what is in the running program, not when something goes wrong. So assertions are more for program correctness and logic errors, and exception handling is to handle problems in the code when you try and run something. So there's a brief breakdown of the two, looking at the differences. So exception handling deals with unusual circumstances and addresses robustness. Robustness is, can we recover from a problem and continue operation? Assertion is used for correctness. Is my program doing the right thing? And it's always runtime, and you can turn it off if you want to. Exceptions, you can't turn off. It's always on. Okay. So now that you sort of looked at exception handling, and again, you'll look at the code for this in the tutorial tomorrow. Now that you sort of know about exception handling, we can talk about text I/O. So with text I/O, before we get to that slide, with text I/O, exceptions will be thrown. Checked exceptions will be thrown. We need to handle those checked exceptions. So that's why we need to talk about exception handling first before we talk about text I/O. So what is text I/O? What is I/O? What is a file? To answer all of those questions, we need to talk about persistence. What is persistence? When you run a program, and let's say we're writing a simple program which says, please enter your name. You enter your name, press enter. It says hello, and then your name. When that program finishes execution, is that name stored anywhere? Can I get access to that name in future? When you write programs that just work in memory, those things are only available while the program is running. As soon as the program exits, then you have no longer access to any of that information. Now, we develop computer systems to store information, or use stored information. So that's where persistence comes into play. Persistence means it stays behind, persists. So one way of having persistence is having data stored somewhere. And the easiest way we can store data is something we can understand as human beings, and that is in text files. It's text, I can read it. I can open the file, I can read it. So the reason why we have text files is we can save information and use it again a bit later. Now, with files, you can have binary I/O as well, instead of just text, where a computer will better understand what's going on in there than us. And we'll look at the benefits and the not so great things about working with binary files. Another concept which is going to be important, which we're not going to go in too much depth, is talking about absolute and relative paths. We sort of brushed on this when we talked about command line arguments and working with the command prompt. And absolute address, absolute file name, absolute path tells you exactly where something is. So for example, the path that's specified there, and again, it will be Windows examples because that's the machines that we have in the labs, and that's the examples which I can provide to you without any problem. If you look on the C drive under a folder called My Upload, under a folder called Source, you'll find something called exception.java. That's an example of an absolute file path. Tell you exactly where to go. Go to the C drive, go to this folder, go to this folder, to that file. Then we have something called a relative path or relative file name, and that's relative to where you are right now. So in the current folder, look for a source folder, and in that folder, find exception.java. So that's relative. It's depending on where you are right now. If someone is giving you directions, they might say, oh, where are you from right now? Go out the door, turn left, turn right, turn left, turn right, and you're there. That's relative because they're telling you from where you are right now. But if you're asking to go from a certain location to another location, to go from ELS 200 to the Academy's front office, you need to go out the door, go past the print station. At the print station, you need to turn left and then turn right, and you're at the window for the administration. That's absolute, telling you from a reference point to another reference point. So it's very important that you know the difference between the two, because when you work with files in your projects, you're going to use relative paths, because in your project folder, you have something called the data folder. Remember that folder? That's where all your data files are going to go. And if you look under additional files for Practical 02, you'll see there's the data files provided for you in a data folder. Now, in order to work with files, we need something called a file handle. With a file handle, it basically tells us that this is something that can work with the file. We can't use file handles to read and write. It just gives us a way to access information about the file. In order to read and write to a file, we need to work with file streams, and that's what we will have a look at in just a moment. So with the file handle class, there's a couple of methods that are available that can help us out. There's something called exists. If the file handle exists, the file exists somewhere on the machine, whichever computer we're working with. Length returns the number of bytes of the file, so what size it takes up on the actual disk. Can read and can write. For our purposes, most of the time, these will both return true, but that might not always be the case. If you're looking at any computer system, usually there's an administrator account and a normal user account. And some places, the normal user cannot write information, but they can read information. Some places, they can't read information, but they can write information. So those will change depending on where you're working. Now, for our purposes, most of the time, I'll say 99% of the time, can read and can write will return true, which means we can read and write to that specific file handle, not through the file class, through another means, but it is available. Then is file and is directory. That will indicate, is the file handle that we're looking at, is it actually a file or is it a directory? Is it a folder? For a computer, for the operating system, it doesn't care about the difference. To it, everything is just ones and zeros. For us, it matters because we need to organize things in something that's logical for our needs. And then get relative file path, get absolute file path. Does what it says. It will get the relative path from the current working directory, or it will get the absolute path telling exactly where that file is. Obviously, there's a lot more. If you want to find out more, where do you look? Javadoc. Javadoc will tell you all the other things you need to know about the file handle class. If you want to write files, you can use something called the print writer. Now, with the print writer, we're actually using a print writer already. If you look at the methods that are available, you might figure it out, or the variable names for that matter as well. So here's an example of writing to a file. Notice where we declare certain variables. At the start of this method, you can see there is a file handle being created. A file handle cannot be used to write the file. We need something else to write to the file. And to do that, we're going to use something called a print writer. Now, the reason why we're doing certain things here will be more clear when we look at the code in the tutorial tomorrow. But what you'll see on line 4, we declare a print writer equal to null outside of our try block. So I'll talk about why it's outside in just a moment. Then inside our try block, we create a new instance of print writer, passing our file handle as a parameter. At that point in time, that's when one of the exceptions can be thrown, and that is the exception in our catch block, file not found exception. A print writer cannot be created on a file that does not exist. So file not found exception. To write to the actual file, we have to call methods that are available in the print writer class, and one of those are print line. Where have you seen that before? Where have you seen print line before? System out. System out, the type of that variable is print writer. Except we're not writing to a file, we're writing to a stream, specifically the output stream of the program. So there in our catch block, you'll see there's something called the FNF exception, file not found exception. You can provide a different variable name if you want. Usually I have them as the sort of the name of the exception itself. And the method that we're calling there is something called print stack trace. All this does is print an error message to the error stream indicating what the exception that is occurring at that point in time. We can write a custom message if we want to, depending on what application you are using it in. And then in the finally block, as we mentioned previously, once we're done working with the file, what we're going to do, we're going to close the file. But there's a problem, and this is the reason why we have print writer declared as null before our try block. If on line 6 an exception is thrown, what is the value of txt out? If on line 6 an exception is thrown, what is the value of txt out? It's null. Can I close a null reference? No. But if line 6 works fine, line 8 works fine, what is the value of txt out? Some memory location that points to the print writer. And can I close that thing? Yes, it's a memory location that points to a valid thing. I can close it. So that's why we have in our finally block first a null check to check if my print writer is not null. If it's not null, I can close. I'm missing a semicolon there, but I can close. Otherwise, if it is null, I can't close anything, so that's fine. Just leave the method, the rest of the method as it is. When we need to read, we can press something very similar. Obviously, with reading, there's going to have a way to read from the actual thing. I see I am out of time, so I'm going to stop there. We'll look at the rest in the tutorial tomorrow. So we'll look at automatic resource management, which does things some of the things automatically, which is very nice, but we'll see that in tomorrow's tutorial. If there's any questions, I'll be here in the front. Otherwise, I'll see you tomorrow.